In this video, we'll be looking at the graphs of sine and cos with a focus on amplitude and period. In these examples here, the amplitude and period are not the conventional 1 for the amplitude and 1 for the period, or 1 for the n value. So we'll look here and investigate each case and what the graphs or the default graphs will look like. In this case here, our amplitude is 2 for our first example. And this 3 here represents the n value, so that when we calculate our period, which is calculated by 2 pi over n, we can substitute it in and we get a period of 2 pi on 3. So what does this look like? Our mean line will give us a value of 0 because the graph has not translated up or down. And from there, our amplitude will go up by 2 and it will also go down by 2 to negative 2. Please excuse me, these lines are not very straight. I will redraw them again and I'll duplicate them instead. Okay. Our graph starts at an x value of 0, and let's say it ends at the end of the period, which is 2 pi and 3. We can split these up now. So halfway, we will multiply the denominator by 2, which gives us a fraction of 2 pi on 6. And if you want to simplify it, you can write pi on 3 instead. And half of pi on 3 is pi on 6. If we multiply the denominator by 2 again, and if we multiply pi on 6 by 3 to get our third increment, we'll get 3 pi on 6. But again, we can simplify that to pi on 2. Now, when we go to sketch up our graphs, what will be important are just the first 2 increments of your graph. And the graph for a sine graph, notably a positive sine graph, will start in the middle and it will make its way up to the maximum line, back down to the mean line, down to the minimum line, and back up to the mean line again. So going from 0 to 2 pi on 3. An important note here is to know what our first 2 points will be, and this will become more important when you start to sketch graphs with particular domains. In our second example here, we have an amplitude of 1/2. Now amplitude here, it does say negative at the front, but the negative there represents a reflection in the x-axis, which means that our graph will flip upside down instead. Now amplitude here, if you do happen to take the negative in, we introduce this idea of a modulus, or an absolute value, which makes the value inside those straight lines positive. So amplitude will always be positive. In this case here, our n value is not over 2, or it's not 2. Our n value is actually 1/2 inside the bracket there. So to calculate our period, it's 2 pi over n, which is 2 pi divided by 1/2. Now, people can easily get confused with this, but if you rewrite it as 2 pi divided by 1/2, like so, then you can apply the keep, change, flip principle. Keep the 2 pi, turn the divide into a times, and then flip the 2, so it becomes 2 over 1, which gives us a domain of 4 pi, or period of 4 pi. Similarly, again, we're going to draw out our mean line now. So our mean line here is 0. Our amplitude is 1/2, so we go up by 1/2. We go down by 1/2. Then we focus on our period here, which goes from 0 to 4 pi. Halfway is 2 pi. 1/4 is pi, and 3/4 is 3 pi. Our graph this time, however, because it is a negative sign, sine still starts in the center line, but instead of going up like our previous graph, which is a positive graph, we will be going down. And the pattern continues. The wave pattern continues. Like so. That last segment there, I might redraw. Not so nice. There we go, a bit better. Okay, in our last example here, I might just move this a bit down. Our amplitude is 4 for a cos graph this time. Our n, in this case here, is 3 pi, because our variable in this question is x. So the n value is the coefficient in front of that x, which is 3 pi. We're going to apply our formula here of 2 pi over n. Make the substitution of 3 pi. Now you'll notice that the pi's will cancel out. So you end up with a period of 2 over 3. What will this basic graph look like? Again, our mean line, we have not added a number on the end, so our mean line will be at 0. Our amplitude this time is 4, so we're going to go higher up, all the way down to -4. And we're going to break it up so we get our period now. So start at 0 again. We end at 2/3. Now if we break it in half again and we multiply by 2 in the denominator, we will end up with 2 over 6, which is the same as 1 over 3. If we multiply this by half again, we end up with 1 over 6. And then if we multiply that 1 over 6 by 3, we end up with 3/6, which is the same as 1/2. We are sketching a cos graph this time. So for our cos graph, we start at the maximum, go down to the mean line, down to the minimum, back up to the mean, and back up to the maximum. Now remember, for each of these graphs here, you only need the first 2 increments. Once you have the first 2 increments, then you'll be able to sketch up the remainder of the graph when it is more complicatedly transformed, when there are more transformations involved.